So in this video, I want to go over Newton's third law. And the key point of Newton's third law is that there never exists just one isolated force in nature. You can't think of one single example when there's just one isolated force. All forces come in pairs. Whenever there's one force, there's another equal and opposite force. So what's an example? Let's say we slap this red rubber ball. So let's say we slap this ball and we apply a force on this ball. So we know if we slap this ball would feel a force. Let's say it feels a force of 10 newtons. So again, we slap the ball. We slap this ball. Now this ball feels a force of 10 newtons. But again, we know from Newton's third law, there never exists just one isolated force in nature. There's not one single example you can think of when there's just one isolated force. All forces come in pairs. Whenever there's one force, you know there's another equal and opposite force, and that will always be true. So what is the equal and opposite force? Well, our hand will feel a force. Our hand will feel an equal and opposite force of 10 newtons. It's equal in magnitude, but opposite in direction. It's going in the opposite direction. And again, we know this because, again, imagine if you close your eyes. Imagine closing your eyes and slapping a ball. If you slap a ball, you'll feel it. You'll feel that force. If you know you've slapped the ball, because you'll feel that force. So that's the equal and opposite force. So when you slap the ball feels a force of 10 newtons, and that's why the ball starts moving, it feels a force. And we know forces cause accelerations. So again, we slap the ball, but we know this force, there never exists just one isolated force. We know all forces come in pairs. We know all forces have an equal and opposite force. And that equal and opposite force is the force our hand will feel. Our hand would feel that slap. And we could feel it. We could close our eyes and we know we hit the ball because we would feel that equal and opposite force. And again, we know they're equal in magnitude. They're the same amount of newtons, but it's opposite in direction. It would go in the complete 180 degrees opposite direction. And something else important to note are these equal and opposite forces will never be on the same object. For example, if we slap this ball and we know it feels a force of 10 newtons, we know its equal and opposite force won't also be on the ball. We know the equal and opposite force must be on a different object, our hand in this example. And again, so the key points is whenever there's a force in nature. For example, if we slap this ball and there's a force, there has to be an equal and opposite force. And that equal and opposite force must be on a different object. There'll never be one object that feels both equal and opposite forces. Because if you think about it, that wouldn't make sense. If this ball felt both equal and opposite forces, it wouldn't move. It would feel the 10 Newton force in this direction and the 10 Newton force in this direction, and it would never move, and we would never have movements. So these equal and opposite forces are always on different objects. So now I want to go over a tricky example, and if this is confusing the first time you see it, don't worry. This is a pretty complicating topic in physics, so don't stress about it too much. But again, just here's an introduction. So let's say we have this textbook. We know if we had this textbook and we threw it off a table, we know it would feel a force downward. It would feel that force due to gravity. So again, we know this just due to this object having mass, we know it feels a force of gravity, a force downward. So therefore, we know this book feels a force downward, that force of gravity. That force of gravity. But again, we know all forces have equal and opposite forces. So what's the equal and opposite force? We know that equal and opposite force must have a same force that's equal in magnitude, but opposite in direction. So what is that equal and opposite force? And we also know that equal and opposite force must be on a different object. So what is that object? Well, that object happens to be the Earth. And again, in my gravity video, I talk about all objects with masses feel those attractive forces, those forces due to gravity. So these are the equal and opposite forces. So again, we know if we throw a book off a table, we know it would fly downwards because it's feeling a force. It's feeling a force, and that's why it flies towards the ground, towards the center of the Earth. And again, we know forces are never isolated in nature. All forces have equal and opposite forces, equal in magnitude, opposite in direction. And again, we know that equal and opposite force must be applied on a different object. In this example, it's the Earth, this Earth, that feels that equal and opposite force. So now that we know that, however, notice This book, if it's standing on this table, we know it's feeling that force due to gravity. We know it's feeling that force due to gravity, so we know it's feeling a force downward. However, this book isn't moving. We know this book is standing on this table. We know it's not moving. So therefore, if this book isn't moving, it must be feeling no net forces, because again, we know force equals mass times acceleration. So if this book isn't moving, we know it must have no acceleration. It must have no acceleration because it must have no net forces. So therefore, if this book isn't moving, we know it must be feeling no net forces. So therefore, we know it must be feeling a force in this opposite direction. That balances this force, so therefore there's no net forces, so therefore no acceleration. Because again, we know this book has no acceleration in this x direction, in this y direction, so therefore it must have no net forces in the y direction. So therefore, we know this book must be feeling a force in this y direction. Because again, it's not moving, and we know it feels a force of gravity. So what's going on with this force? Well, this force is the normal force. So what's this normal force's equal and opposite force? Well, we know this normal force, because again, we know this book isn't moving, so we know it has no net forces. So therefore, we know there must be a force moving it upward, because we know there's a force moving it downward due to gravity, so there must be a force moving it upward. So what's going on with this force moving it upward? And what's this force's equal and opposite force? Well, again, we know all forces have equal and opposite forces. So therefore, the equal and opposite force is the force this table is feeling. This table is feeling a force downward, so opposite in direction, but equal in magnitude. So again, we know those equal and opposite forces must be on different objects. We know an object can never feel both equal and opposite forces. And again, we know this table is feeling a force. Because again, if instead of this table, let's say we had our hand here. We know we would feel a force. We would feel a force. If we had a book on our hand and close to our eyes, we would know that book was there. We could feel that force. But instead, let's say it's a table. We know that table must be feeling a force. So these are the equal and opposite forces. Equal in magnitude, opposite in direction. They point 180 degrees away from each other, and they're on different objects. So that's what's going on. So these are the equal and opposite forces. And something that people get confused is they think these are the equal and opposite forces, which is not true. This guy's equal and opposite force is coming from the Earth. Because again, those equal and opposite forces can never be on the same object. There can never be one object that feels feels one force and also feels that force's particular equal and opposite force. That never occurs. Whenever there's one force, we know the equal and opposite force must be on a different object. So that's what's going on here. So again, the key point of Newton's third law is there never exists just one force in nature. You can't think of a single example when there's just one force. Whenever there's a force, there's an equal and opposite force. Equal in magnitude, the same amount of newtons, opposite in direction, and you know those equal and opposite forces can never be on the same object. If one object feels one of those pairs of those equal and opposite forces, the other equal and opposite force must be on a different object.